Radiation is a natural part of our environment, constantly present and originating from various sources. This ever-present radiation is known as background radiation, and it comes from both natural and human-made sources. Natural sources include cosmic rays from outer space, radon gas released from the Earth's crust, and naturally occurring radioactive elements like uranium and thorium found in soil and rocks. Additionally, certain foods, such as bananas, contain small amounts of radioactive isotopes. Human activities, such as nuclear power generation, medical procedures like X-rays, and past nuclear weapons testing, also contribute to background radiation. Despite its ubiquity, background radiation is generally low-level and poses minimal risk to health. When a person or object is exposed to radiation from a source, this exposure is referred to as irradiation. Irradiation occurs when radiation from an external source passes through an object or person. This type of exposure does not make the object or person radioactive because the radiation simply passes through or is absorbed by the body without causing the transfer of radioactive material. The extent of harm from irradiation depends on the type, intensity, and duration of the radiation exposure. For example, exposure to high doses of radiation in a short period can cause acute health effects, while lower doses over a longer period may increase the risk of long-term effects, such as cancer. Contamination, on the other hand, involves the unwanted presence of radioactive particles on or within objects, people, or the environment. This can happen when radioactive materials are released into the environment, either accidentally or through human activities, and then come into contact with surfaces or are inhaled or ingested. Unlike irradiation, contamination means that the radioactive material itself is present and can continue to emit radiation. Contamination is particularly hazardous because it can lead to prolonged exposure to radiation, especially if the radioactive material enters the body, where it can cause localized damage over time. The seriousness of both irradiation and contamination depends largely on the source of the radiation or radioactive material. Factors such as the type of radiation emitted, alpha, beta, or gamma, the energy level of the radiation, and the duration of exposure all play crucial roles in determining the potential health risks. For example, alpha particles, although not penetrating, can be extremely harmful if radioactive material emitting them is ingested or inhaled. Gamma rays, being highly penetrating, pose a greater external risk but are less harmful if the source is kept at a distance or properly shielded. Therefore, understanding the nature of the radiation source is essential in assessing the risks associated with irradiation and contamination and in implementing appropriate safety measures.